In fact, comfortingly, if you ask people do they trust scientists, depends what you call them. If you ask them and call them scientists or professors, that's okay. If you start parsing them as government scientists or independent scientists or environmental scientists, then you do tend to get shifts. But by and large, we're right up. This was a study commissioned by doctors to reassure themselves that they were the most loved and trusted, and indeed they are. But we're right up there with them. And particularly interesting and perhaps surprising is that younger people in this study show more trust of most sectors, with some revealing counterexamples. I think particularly interesting is the one about the ordinary person in the street. Secondly, there's this broad feeling that if only people understood science better, there'd be less trouble, less worry. And this is rather old data. It's an old Eurobarometer survey, but it asked people in the EU 15, as it was then, questions about science, not trivial things like does the sun go around the earth around the sun, but what do you mean by a control group? What do you mean by a confidence interval? And you see there's quite a gradient from 70% scores to 30% scores, and with some exceptions, it's a north-south gradient. But then you ask the same people, do you think science has on the whole made life better? On a score from 1 to 5. Everybody thought it made life better, but the people who were really sure it made life better were, by and large, the people who knew least about science. Now, I am sometimes mistaken when I say this as advocating that we should abandon trying to engage the public in science or teach them science to make life easier for the science community, but I'm not. I'm saying this is sensible. The more you know about science, the more you know about unintended consequences. And the final one in my triad is science itself. Those first two were misunderstandings prevalent in the science community about the outside world. This is a misunderstanding prevalent in the outside world, which is that science is the thing that gives you the answer. It's an understandable but very unfortunate misunderstanding. It's understandable because how you encounter science in school, primary, secondary, most of tertiary, is the stuff we really know. I mean, how else do you organise the curriculum? And when you see science in University Challenge, vexed topic at the moment, or on quiz shows in general, you can't have a quiz show where the answer to the question is the subject of debate. There's got to be an answer, even if sometimes, if you do give the right answer and it's not on Paxman's scorecard, he stops sneering at your ignorance of the arts and commits a colossal bloomer in the sciences, but let that pass too. I particularly like the one where the answer was 1, or unity, and the person said unity. Wrong, the answer's 1. Or the normal distribution. Wrong, the answer's the Gaussian distribution. Anyhow, I digress. It's unfortunate because although a lot of stuff is well understood, it's the very things that people tend to be worried about that emerge partly because they are at or beyond the frontiers of what we know well. Things like, will BSE jump across to humans and create some problem? To what degree might GM crops hybridise and, if they do, create problems? How fast is climate change occurring, with some of the non-linear questions to do with it? And in general, a failure to appreciate that in these areas, science is as much a way of knowing, it is as much a way of asking questions, it is more organised scepticism than clear-cut answers. And that's something we need to do a better job of making clear. Now, that's not to gainsay that the great majority of science advice in government policy is based on routine, well-explored, well-understood areas of science, so that the public expectations, just tell us the facts, do march with our actuality. But what we need to do is do a better job of both recognising and conveying the recognition of those topics and areas where there's significant uncertainty and where science is a way of framing the questions. For most of science advice in government, you need to be aware of the most recent things that have happened, and you need to convey that understanding accurately to people, but you don't need superstars to be entrained in the process. Good, ordinary, competent scientists will be more than good enough. But once you're at or beyond the frontier, you have to be much more careful about being sure you've got the best people who are going to be, amongst other things, comfortable telling you they don't know, rather than taking the question and trying to tell you some different question's answer that they do happen to know, which is prone to happen. And ultimately, of course, you run into a question of who decides which are the things that are well known and which aren't. And that involves a more sophisticated understanding of the nature of the scientific process than we usually succeed in conveying more generally. When I was president here, I got a surprising amount of correspondence from aggrieved people who had invented perpetual motion machines and felt unappreciated. And I had a standard letter that said, "Thank you for your letter, but it contradicts the second law of thermodynamics, and therefore I haven't taken the time to find out what's wrong with it, but you should get stuck into that." More generally, and I have a metaphor that I'm perhaps over fond of, and some of you may have heard me expound it before. I think in any given topic in science, some of them, of course, well in the past, in the early stages as we begin asking questions, there are lots of ideas contending. That's like a landscape with lots of little hillocks of ideas. As time goes on, and particularly after the Enlightenment, over the last 3 centuries and more, as we've invented systematic ways of exploring and discriminating with increasingly well-designed experiments, some of these ideas can be ruled out. Others will still grow. Sometimes there'll be two contending schools. Sometimes it'll turn out that apparently different things coalesce, which is a bit of a problem with the metaphor of a landscape, I admit, a sort of landscape with moving continents, if you like. And eventually, there will be one agreed peak. Of course, it'll never be quite that simple. As long as some of the other peak supporters are alive, there are many of them who will never give up, and Max Planck memorably, I think it was Max Planck who said there are some things that are never resolved until some of the protagonists die. And in some issues, like, for example, Star Wars, you have deliberate deceit within the scientific community, deliberate knowing, falsehoods and manipulation of the facts. But in general, the things we really understand, the first and second law of thermodynamics, Newton's first and second law, and think how non-obvious they were before we knew them. I mean, the first law, body tends to stay in its state of rest or uniform motion in a straight line, except insofar as external forces. What an implausible statement in a world where friction and gravity means that nothing moves in a straight line unless it's acted on, because it's always acted on by external forces. But once we've established that, there become areas of certainty, subject to the problems I just said, and subject to the fact that everything is always contingent, and thus Newtonian physics has indeed given way to post-Einsteinian physics, with the difference, however, that for almost all applications, we can deal with the non-relativistic limit, and nearly all our maps work, except in the odd circumstances when they don't. And I went on about that. I could go on at that much greater length, but what I'm trying to make clear here is that in the early stages, you have to encourage dissent and ideas, whereas in the later stages, you have the problem of getting people to recognise that these ideas have provoked discriminating experiments, and today is not 20 years ago. Today in climate change is not the state of uncertainty of, say, 30 years ago, because the computational power that we've had to bring to bear on it has doubled every 18 months over those 30 years.